Okay guys, our goal for this video is to go over how to find the area between two curves. We are starting Unit 8, which is talking about area and volume. So to begin with, let's do a quick review of how to find area under a curve. So if I want to find the area under the curve of y equals x squared on the interval from 0 to 2, that means I want to find this pink area. And I have to use an integral here because I don't know how to geometrically find that area. So I have to do the integral from 0 to 2 of x squared dx. Okay, which I could do this by hand. X to the third over 3 from 0 to 2. Plug in 2. And then plug in 0. So we're left with 8/3. Okay, now remember, you could also do that exact same process in your calculator if it were a calculator question on the AP test. Okay. All right, if I want to find the area under the curve of this equation from 0 to 2, well, for this one right here, that area between the curve and the x-axis. Remember, integrals always give us the area between the curve and the x-axis. Okay, so that's very important to remember. So if I want to find this area, I could do it geometrically by breaking it up. Okay, so that would give me an area of 4. This would give me an area of 1/2 2 times 2, which is 2. So my total area there would be 6. Or I could go and do the integral. Okay, so I would get x squared over 2 plus 2x from 0 to 2. Okay, when I plug 2 in, I'm going to get 2 squared over 2 minus 2 times 2. And I know in this specific problem, if I go and plug 0 in, I know I'm going to get 0, so I'm not even going to bother to write that down. So 2 squared over 2 is going to be 4 over 2, which is 2. Plus 4 is going to give me 6. So I got the exact same answer doing it algebraically or geometrically. Okay, so that's going to give us the area underneath of each of those curves. But now I don't want the area underneath each of those curves. I want the area, between the curves. Okay, so if I take the area under this curve, the line curve, the linear function, and I subtract this area, it's going to leave me with this missing area that I'm looking for. So if I want the area between those two curves, I'm going to do the integral from 0 to 2. I always want to do the top equation first because that's like my larger amount of area. Okay, so I want to do the top equation, so that's x plus 2. And notice how I'm using parentheses because that's going to be very important. So the top equation minus that pink area. So that pink area is x squared. So by subtracting those two areas, I can get the area between the two curves. Now, in this problem specifically, those parentheses aren't necessarily important. Using our properties of integrals, I know that I could break this down into that integral minus that integral. Okay, and the reason why I did that here is because we have actually already figured that out. This integral is going to be 6. That integral is going to be 8/3. Okay, so if I need to subtract those, I want to give them a common denominator. So 6 is really going to be 18/3. minus 8/3 is going to give me 10/3. Okay. Now, I also want you guys to remember that you can do this completely in your calculator, okay? If you were to go and use Math 9, okay, and most of the time, not most of the time, but there's a good portion of the time that these are going to be calculator questions for you. So we can just do the integral from 0 to 2 of x plus 2 minus x squared dx. Okay, if you put that in your calculator, take a second. I'm going to do it, so you got a chance to do it on your own to check with me. So everybody try it. And I actually came out with 3.333. Now, in your calculator, if you hit the math button and then pick the fraction, so math, it's usually just math enter. Oops, mine's not working. But that will give you 10/3 as your answer. So we know that that's equivalent to it, okay? So the basic ideas that I want you guys to grab from this is that if we're gonna find area between two curves, okay, we're gonna do the integral of f of x minus g of x. And the key things we have to remember here is that f of x has to be your upper function. It has to be the one on top. And g of x has to be your lower function, okay? G of x is on the bottom, f of x is on the top. Now, if for some reason g of x was on top, then you could flip-flop that around. Now, also remember that we have bounds here too. They only want us to find it from A to B. So those points will most of the time be given to you unless for some reason f of x and g of x intersect. If f of x and g of x intersect, then you might need to go to your calculator to find those intersection points, okay? So let's do an example. We want to find the area of the region bounded by y equals x squared and y equals the square root of x. So bounded, that's a key word there that's going to tell me that these 2 points, we're going to have 2 intersection points here, okay? And in this first one, they're giving you the graph. We're going to do the same question again where you're not given the graph, okay? So if I'm given the graph, I know right away that this function right here, let's use better, that this pink function right here is going to be my top function, okay? And I know that this function right here is going to be my bottom function. The only thing I care about here is where it's bounded. So I only care about what's in between those intersection points. That's the area that I'm trying to find here, okay? So what x values am I going through? I'm going from 0 all the way to 1. So the integral from 0 to 1 of the top equation, which is the square root of x, minus the bottom equation, which is x squared. Okay. If we had more complex equations here, we would want to make sure that we have parentheses when we subtract, but since we have simple equations here, I skipped out on the parentheses. Okay. Now, could I do this by hand? I could do it by hand. We're going to actually take time on the next one and do the next one. We'll do it completely by hand once we know the answer. So let's do Math 9 in the calculator. We want to go from 0 to 1 of the square root of x minus x squared dx. Okay. When I do that in my calculator, I come out with 0.333, which everybody should be able to recognize that that is 1/3. Okay, so that's telling me that the area between the area of the region bounded, we'll say, bounded by x squared and the square root of x is 1/3. So that's giving us the area of that little shape right there. Okay. That has an area of 1/3. Okay. Now, when you're given the graph, it's very easy to visually figure out which one's the top equation and which one's the bottom equation. If for some reason, let's say, we are not given the graph, okay? So if I'm not given the graph, there's a couple things that I need to figure out here, okay? I have to figure out, first of all, where do these two equations intersect? And I also have to figure out, well, which one's the top and which one's the bottom. Now, you might be able to tell just by knowing your function families, which one's the top and which one's the bottom, but I'm gonna go through the process as if you don't know, okay? So we wanna find the point of intersection. So I'm gonna figure out, where is x squared equal to the square root of x, okay? So let's start by squaring. Oops. If I square both sides, I'm going to be left with x to the 4th equals x. Okay. Then I am not going to divide by x here, because dividing by x, I'm going to get rid of a solution. I'm going to turn this into the x to the 4th minus x equals 0. And then I'm going to factor out an x. Okay. And then I'm going to set each factor equal to 0. So I get x is 0 and x is 1. So that right away tells me that my interval is going to be from 0 to 1. Okay, so I know that my integral is going to be from 0 to 1. I just have to figure out now which one's going to be the top and which one's going to be the bottom. Okay, so if you're not sure, let's pick something in between my interval. So anything in between 0 and 1, I'm going to choose 1/2. Okay, if I plug 1/2 into x squared, I'm going to get 1/4. Okay, if I plug 1/2, actually, you know what? I'm going to change that. I'm going to make this 1/4 because that's going to make it easier. I'm going to choose 1/4. So that's going to give me 1/16. Now, when I do the square root of 1/4, the square root of 1 is 1, and the square root of 4 is 2. Okay? So looking at that, I need to know which one's bigger. The bigger one is going to be the higher y value. So this is telling me that I have, if this is 0 and this is 1, and I'm at 1/4, right? If I plug in x squared, I get 1/16. But if I plug it into the square root of x, I get 1/4. So this is going to be my top equation. Okay, this is going to be the top. This is going to be the bottom. Okay, so that lets me know that I'm going to have to do the square root of x minus x squared. So if you're ever in doubt of which equation is on top and which equation is on the bottom, pick a point that's in between your interval, plug it in, and see which one has a bigger y value. The bigger y value will be the equation that is on the top. Okay? So now let's actually go through real quick just to review the integral from 0 to 1 of the square root of x minus x squared dx. Okay, because a lot of times when you have to do this where they don't give you a graph, you don't have a calculator to use. Okay, so I need to do the antiderivative, and remember, I'm going to rewrite that as x to the 1/2 first. Okay, when I do my antiderivative, I'm going to add 1 to the exponent and divide by my exponent. Add 1 to the exponent, divide by the exponent from 0 to 1. Okay? I'm going to take a minute and rewrite a little bit first because I don't like fractions inside of fractions. So dividing by 3/2 is the same as multiplying by 2/3. And I'm just going to make, I'll leave that. Okay, so now let's plug in. If I plug the 1 in, I'm going to make this like this, just to organize for us. If I plug the 1 in, I'm going to get 2/3 of 1 to the 3/2 minus 1 to the 3rd over 3 minus 2/3 of 0 to the 3/2 minus 0 to the 3rd over 3, which over here I can see that's all going to cancel out. Okay. So I'm left with 1 to the 3/2 really means the square root of 1 to the 3rd, right? So 1 to the 3rd is still 1, and the square root of 1 is still 1, okay? So that's going to be 2/3 minus 1/3, which leaves me with 1/3 as my answer, which if we were to check back, that is the same thing we got up here when we did it in the calculator, okay? So evaluating an integral, you can do it with antiderivatives, you can do it with the calculator, or you can do it with actually physically finding the area under the curve geometrically, okay? All right, last example. Find the area between the curve of y equals x and the curve y equals x squared from 2 to 4. So notice, this time you're given the interval. You don't need to find the points of intersection. However, you don't know which one's the top equation or which one's the bottom equation. So we have to pick a value in between and test it. So between 2 and 4, let's check when x is 3. Okay, when x is equal to 3, I'm going to have y equals 3 squared. And I'm going to have y equals 3. Okay, get y equals 3 here, and we're going to get y equals 9 there, right? So y equals x squared is going to be the top equation, and y equals x is going to be the bottom equation. Okay, and I have this graph over here just so you can see it. This is what y equals x squared looks like, and this is what y equals x looks like. That is just there for the visual checkpoint. Normally, you would not be given that in this case. Okay, so we want to find that area between the graph. So we're going to do the integral. They gave us the interval from 2 to 4. Okay, the top equation is going to be x squared. The bottom equation is x. Okay, we're going to treat it as if we don't have a calculator. So I'm going to find my antiderivative, x to the 3rd over 3 minus x squared over 2. From 2 to 4, focus on notation, guys. We should make sure that our notation is accurate every time we're doing this, okay? And now we need to do top minus bottom. So 4 to the 3rd over 3 minus 4 squared, always use parentheses, over 2, minus 2 to the 3rd over 3 minus 2 squared over 2, okay? Open response question on the AP test. You are totally allowed to leave your answer exactly as it is right there, and you can stop, okay? For the sake of, just practicing, we are going to go through and actually simplify this, okay, without using a calculator. So 4 to the 3rd. So when we go to simplify this, 4 to the 3rd is going to give us 64 over 3. 4 squared over 2 is going to give me 16 over 2. Don't forget to distribute that negative across those parentheses. So we're going to get 8 over 3, and then this minus is going to become a plus, and 2 squared is going to be 4 over 2, which is really just 2. 16 over 2 is going to be 8. We know that. Minus 8 over 3 plus 2. Okay, 64 and negative 8, we can combine to get 56 over 3. And then negative 8 plus 2, we can get negative 6. let's get that into a common denominator. So 6 is going to become 18 over 3. And then when I do 56 minus 18, I'm going to get 38 over 3. Okay, which is going to come out to be, if you were to check this in your calculator, you would come out with 12.667. Okay, so 38 over 3 or 12.667 is our final answer.